Let's take a look at simple and compound interest. Before that, we need to know what an investment is. An investment, such as a bond or putting money into a savings or retirement account, is a way to set aside money for the purposes of profit. So you can put money into a savings account, or you can put it away into some retirement account, and you just let it sit there. And as time goes on, that money will accrue through interest payments. So what is interest? It's a payment made either directly to the person investing or adding to the current amount invested. So there's two types. There's simple interest and compound interest. And simple interest is essentially you get the same amount every single time, and that doesn't change no matter what. So whatever's in the account, you get maybe 5% of that, and then that is applied every single month or maybe every single year. Whereas compound interest, it looks at the account every time it's going to pay you, and then that changes over time, because when you get paid a little bit for that compound interest, it adds to the account, and then the next time it's going to look at the account and it's going to see that there's more money in there, and so it's going to give you the same percentage, but that percentage is now going to be a little bit higher because it's accounting for both what was in there before as well as all of the payments that were made. So let's take a look. This is an example of simple interest. Let's say that you put $1,000 into an account and you're going to get 5%. So at the end of year one, you had $1,000 in there. You're going to get 5% of that, so that's $50. And that $50 goes directly to you. So think of this as the $1,000 stays in the account and you get a check for $50, or someone hands you $50 cash and you've got that kind of in the other hand. And so now at the end of year two, they're going to give you another 5% on that $1,000. And so you end up with, let's say that you didn't spend any of that $1,000 or any of the $50 that you got before. You now have $100 in hand and that same $1,000 in the account. Well, it's going to continue for year three. You're going to get another $50 directly to you. And same for year four. You're going to get another $50 directly to you. So in the account, you can think of this as in the account, you've got $1,000, and cash in hand, you've got $200. Your value for the entire investment is $1,200. But let's take a look at how that compares to compound interest. So let's say there's still that $1,000 you want to put away. At the end of the first year, you get 5%. And so we see here $1,000 plus $50. That's the same. That's $1,050, the exact same as what we had after year one for simple interest. But for year two, now you have $1,050 in the account. So don't think of this as you've got an account with money on hand. That $50 was put into your account. And they see that $50 in the account when they go to accrue the 5% interest here. So 5% of $1,050 is $52.50. So you get an extra $2.50 at the end of the second year for compound interest. They put that into the account, and now you're at $1,102.50. At the end of year three, they see that money, give you 5%, and now instead of $50, it's $55.13. Meaning at the end of the year three, you have $1,157.63. And at the end of year four, same thing. They give you 5% of what they see in the account. That's now going to be $57.88. And so at the end of it all, you have $1,215.51, which is not a lot more, but it is more than simple interest, because if you remember, simple interest was a flat $1,200. Here, you've got an extra $15.51, and that's just after 4 years. Imagine, if you will, if you left it in there for, quite a few more years. Let's say 10 years. Let's say 15, 20 years. the difference between simple and compound is going to grow further and further and further. All right, so what are you going to do then for your assignment? Let's say that I give you this problem here. For compound interest, or for interest that compounds annually, we use the function f of t equals a times 1 plus r to the t. So compounds annually. That means they're looking at the account once per year, and at the end of that year, they're giving you that percentage. So similar to what we were looking at before. A person invests $3,500 in an account that earns 3% annual interest. Find when the value of the investment reaches $10,000. Okay, so there's a few things we need to know. We need to know A and we need to know R. A stands for the amount that I start with, my initial amount. Some people might call this the principal amount. So what do you start with? Well, A in this case is $3,500. All right, what is R? R is the rate. So this is the 3% annual interest. R is going to be 3%, so that's 3 out of 100, which is 0.03. So let's put this together. Using this function, f of t equals a times 1 plus r, so that's 3,500, parentheses, 1 plus r is 0.03 to the t. T is time. I can graph this, and this will be the graph of this function here. So let's grab Desmos, and let's put that in. 3,500, parentheses, 1 plus 0.03. This is to the, instead of t, we'll use x, so that way we can see the graph. Now you'll notice I've got nothing shown. If I zoom out a little bit, still nothing shown. I have to actually go to my graph settings, and I have to change what we're looking at. I always get rid of the minor grid lines. I think it looks better without them. That'll be up to you. That's optional. For the x-axis, this is representing time. So let's start at 0 for 0 years, and let's just go to maybe 40 years or so. The y-axis, this is going to represent the money in the account. So we'll say 0 to, what am I looking for? I want to find when the value reaches 10,000. So let's do a little bit more than that. Let's say maybe 15,000. And there's my graph. So there's two ways to find when this reaches 10,000. The first way is just click and drag and then find when your y value reaches 10,000, which is, let's see, right around here or so, 35 and a half years. The other option is just to make a line that says y equals 10,000. And then you can quickly find the intersection and see that it is 35.5 years. All right, let's do another one. A person invests $200 in an account that earns 6.25% annual interest. Find when the value of the investment reaches $5,000. So again, I need to know what is A and what is R. So A in this case is 200. R, so that's my rate, is 6.25%. So R is 6.25 divided by 100. This is 0.0625. Putting this together, we'll get 200 parentheses 1 plus 0.0625 to the t. All right, then I go back and I grab my graphing tool, and let's change these. This is going to be 200 parentheses 1 plus 0.0625. And I want to know when this is going to reach 5,000. Okay, it looks like I'm off the chart here, so I'm going to change my graph settings. Let's make this just a little more than 5,000, say 7,500. And it looks like I'm going to need more than 40 years. So let's try maybe 75 years. Okay, so I started 200, and this grows and grows, and then now it's going to start rapidly growing. And it's going to take 53 years to reach $5,000. But notice, even though that sounds like a lot of time, notice that it was really, really slow to start. And then at some point right around here, it started growing much faster and much faster. Okay, so this is 53 years. So we just talked about interest that compounds once per year. Well, what does it mean to compound more than once per year? Here we've got, for interest that compounds more than once per year, we use the function f of t equals a times 1 plus r over n to the nt. The difference here between one time per year and many times per year is that instead of 1 plus r, we're dividing r by n. And then instead of bringing this to the power of t, we'll be bringing this to the power of n times t. Now, what is n? N is the number of times the interest is compounded per year, so compounded annually. If it's semi-annually, so if it's compounded twice a year, then n equals 2. For interest that's compounded quarterly, there's 4 quarters in a year, every 3 months, so n equals 4. And for interest compounded monthly, there's 12 months in a year, n equals 12. What you can think of this is, let's say that we are compounding semi-annually and the interest is 4%. Well, that means that after 6 months, half the year, you're going to get 1% added to the account. And then after the second half of the year, it's going to look at what's in the account and then give you the remaining 1%. If it's compounded quarterly and it's 4% annual interest, then every 3 months, it's going to give you 1% of whatever's in the account. So after the first 3 months, it gives you 1% of whatever's in the account. And then after another 3 months, it looks at what's in the account again, and it bases off of that, gives you another 3% or another 1% of the 3% remaining. And then another 3 months goes by, gives you another 1%. And then finally, the last 3 months, and it'll give you the last 1%. So it's just kind of asking, how are we divvying up this percentage over the entire year? Is it going to be given to you all at once? Is it going to be given to you in, half now, half later? Is it going to be given to you in quarters, or so forth? So number 3, a person invests $1,200 in an account that earns 2% annual interest, compounded quarterly. So this part is important. N equals 4 because this is quarterly. Find when the value of the investment reaches $1,500. So there's a few things I need to find. I need to find A. So A is how much we start with. That's 1,200. I need to find R. R is 2%. So I'll say R is 2 out of 100. This is 0.02% or 0.02. And then N is how many times we're compounding per year. So this is quarterly, N equals 4. Let's put this all together, and I will get 1,200 parentheses 1 plus R over N. So that's going to be 0.02 over 4. And this is to the N times T. So this will be 4T. Or when we go to graph, this will be 4X. All right, let's grab the graph and start plugging away. So 1,200 parentheses 1 plus, let's make this 0.02 over N is 4, and this will be brought to the 4x. And I want to know, when is it going to reach 1,500? Okay, so here is my curve, and 1,500, this will take 11.185, we'll call it 11.2 years. All right, let's do one more of these. A person invests $600 in an account that earns 6.25% annual interest compounded semi-annually. Semi-annually means twice per year. Find when the value of the investment reaches $1,700. Okay, so again, I need to find A. A is $600. That's what we start with. R is my rate, so that's 6.25%. So I'll say here R equals 6.25 divided by 100. So this is 0.0625. And then N is how many times I'm compounding per year. So N equals 2. All right, let's put this all together. And I will get, let's see, 600 parentheses 1 plus 0.0625. This is to the 2 over 2 to the 2t. All right, let's plug it all in. This is going to be 600 times 1 plus 0.0625 over 2 to the 2 times t, or 2 times x here in our graph. And I want to know, when is this going to reach 1,700? Okay, so this is 16.922. That's close enough to 17. Let's call this 17 years, roughly. All right, one last thing to talk about. So we talked about compound interest when we're looking at this just once per year, annually. We talked about multiple times per year. So semi-annually is 2, quarterly is 4, monthly is 12. You could even do daily, which is 365. So in that case, n would be 365. But let's talk about when we're compounding continuously. So this means we're always compounding. We never stop compounding. For compounding continuously, we're going to use a little bit different of a function. V of t equals PERT, p times e to the rt. V, this is going to be the value. So the value over time is equal to P, which is the principal amount invested. That's the same as what we used for A before. So A or P, this is just how much we start with. E, we actually don't plug anything in for E. E is a transcendental number. It's similar to pi. It just represents a number that, just kind of keeps going on and on. So instead of writing it out, we just say this is pi, or in this case, this is E. R is still my rate, and then T is still time. So here we've got a person invests $5,000 in an account that earns 3.5% annual interest compounded continuously. And that's the key word. Anytime you see continuously, you know that you have to use this function right here. Find when the value of the investment reaches $12,000. All right, so the few things we need. We need P, which is, again, similar to A. That's how much we start with. P in this case is 5,000. All right, we don't need anything for E. R is the rate. So R is 3.5%. So I'll say R is 3.5 divided by 100, which is going to be 0.035. All right, putting this together, I get 5,000 parentheses 1 plus, oh no, sorry, ignore that, 5,000 times e. I already forgot. It's continuously. So we have to use this. E to the RT. So up here, I'll do my 0.035. And then T. Okay, so let's change this up. 5,000 E. As soon as you put E, the calculator will understand that is the transcendental number E, not a variable. And then this is to the 0.035. And then we'll use X for T here. All right, and then I want to know, when does this reach 12,000? All right, let's change my Windows settings here. I want to reach 12,000, so we'll do a little bit more than that. Maybe we'll do 15,000 here. Wonderful. So now I can see these intersect at roughly 25, so 25 years. All right, and so that covers our interest lesson. Remember that there are 3 types of compound interest. The first type is when you're going to just compound once per year. So this will say annually. The other type is going to be compounding multiple times per year. So this will say semi-annually, monthly, quarterly, daily. In that case, you're going to use the one that has r over n to the nt, and n is going to represent how many times you're compounding. Now, if it says continuously in the problem, that should immediately mean I have to use this type of function. P times e to the rt. Still find what your initial amount is, your principal amount, what you're starting with, find what your rate is, plug them in, but plug them in this way. And hopefully this helps you out for this assignment. If you have any questions, let me know.